Now let's talk about some periodic trends. When we say periodic trends, we're talking about some behaviors of elements that we can find on the periodic table. Now let's see the periodic trends. Elements in the right-hand top corner of the periodic table are nonmetals. So when we say that, we are talking about the elements over here, the right-hand top corner of the periodic table. They are what we call the non-metals. Now, when you move from left to right on the periodic table, metallic properties decrease. Metallic properties decrease as you move from left to right. So clearly, we now know that metals are usually found on the left. Non-metals are found on the right. Now, for metals, as you move down, the metallic properties increase. When you take metals, as you move down, their metallic properties increase. When you take non-metals, as you move down, their metallic properties decrease. Okay, so as you move across the periodic table, the metallic properties decrease. When you take a metal, as you move down the group, the metallic properties increase. When you take a non-metal group, as you move down, their metallic properties decrease. For this reason, we have francium being our most reactive metal, and then we have fluorine being our most reactive non-metal. The reason is because the most reactive metals are found in group 1. And then as you move down, the metallic properties increase. So once you get to this point, you have your metallic properties being at the highest. Now when you go to the non-metals, as you move down, their metallic properties decrease. So you have your most reactive non-metal at the top, and that is fluorine. Now, in between metals and non-metals are semi-metals, or what we call metalloids. They exhibit both metallic and non-metallic properties. So, for example, when you take silicon, silicon is a metalloid. What does it do? It exhibits both metallic and non-metallic properties. Silicon is a semiconductor. You know, metals are very good conductors. Non-metals are insulators. But silicon being in between the two makes silicon a semiconductor.